Hello everyone, this is the second part of the topic numerical differentiation. In this lecture we will discuss 3-point formulas for approximating the value of the derivative of a function at a point. In the previous lecture we discussed the method of approximation of the derivative f dash of x naught when we are given 2 points x naught and x1. Now, to obtain the general derivative approximation formulas, suppose we have given the n plus 1 points x0, x1, etc., xn in some interval I, and suppose that f belongs to Cn plus 1 I. That is, we are given the points x0, x1, etc., xn. That is, we are given n plus 1 distinct numbers in an interval I, and also we are given that f belongs to Cn plus 1 I. Now we have the formula f of x equal to summation k from 0 to n f of xk lk of x plus x minus x naught into etc. x minus xn divided by n plus 1 factorial fn plus 1 zeta of x for some zeta of x belongs to I, where lk of x denotes the kth Lagrangian coefficient polynomial. So we can approximate f of x as this, that is the Lagrangian polynomial. This is the error term, right? So we have f of x equal to this plus the error term. We already discussed this. Here Lk is the kth Lagrangian coefficient polynomial for f at the points x0, x1, etc., xn. Now we have to approximate the derivative f dash at the point x0. Now, if you are differentiating this formula, we have f dash of x is equal to summation. We know this is f of xk, where k varies from 0 to n. F of xk is a constant with respect to x, so we can take this outside. So this derivative of this is a function of x. Lk of x is a function of x. So derivative of this is nothing but summation k from 0 to n fxk or f of xk into lk dash of x plus derivative of this, that is that is fn plus 1 zeta of x into derivative of this term, that is x minus x naught, x minus x1, etc., x minus xn divided by n plus 1 factorial plus this factor into derivative of fn plus 1 zeta of x. This is actually by product rule. Okay, that is the derivative of these two, product of these two functions. First function this into derivative of this plus second function this into derivative of this. Now suppose x is one of the numbers xj, that is if x is equal to some xj for j from 0, 1, 2, 3 etc. to n, that is suppose x is equal to some x0 or x1 or xn etc. xn. So in that case we know this term will be 0 if x is any one of xj. Then we'll have we have the terms, the factors x minus x naught, x minus x1, etc., x minus xn. So suppose if x is equal to x naught, then we have this. So this term will be 0. If x equal to x1, then also it will be 0 because we have here x minus x1, the factor x minus x1. So it will be 0. If you are choosing x equal to xn, then also this will be 0. So if x is any one of the numbers xj, then this term will be equal to 0. So in that case this formula will becomes f dash of xj, where x is equal to some xj. So f dash of xj is equal to summation k from 0 to n f of xk lk dash of xj plus this term. This term is actually, this is fn plus 1 zeta of x divided by n factorial is here. Then x minus x naught, x minus x1, etc., x minus xn. That is the product k from 0 to n xj minus xk, where k not equal to j. It is because we have the term fn plus 1 zeta of x divided by n plus 1 factorial is a constant here, and here we have to differentiate these values x minus x naught into x minus x1 into etc. x minus xn. For example, if we have this dx of this is equal to this divided by n plus 1 factorial. If you are taking the points x0, x1 and x2, if you are choosing these 3 points only, then we have this product will be this x minus x0, x minus x1 into x minus x2. So dx of this will be this. And here it will be 2 factorial here, that is we have n is equal to 2, so this is 3 factorial, and fn f3 zeta of x will be here. So differentiate this term, this numerator only depending upon x, so differentiating this, that is we have, if you are taking x0 x1 x2, we have these, the numerator will be this, and differentiating this we get x minus x0 x minus x1 into derivative of this x minus x2 is 1 with respect to x, that is plus x minus x naught into x minus x2 into derivative of x minus x1, which is 1, plus the last is x minus x1 into x minus x2 into derivative of x minus x naught, which is 1. So this will be the derivative of this. Now if we are replacing x by some xj, let it be x1. If x is equal to x1, then we know this term will be 0, because we have a factor here x minus x1. So when we replace x by x1, if we replace x equal to x1, we have this will be 0, and this also will be 0. So this term will also will be 0. So the remaining term will be this x minus x0 into x minus x2, right? So that is a x1 minus x0. When we replace x equal to x1, we have only this value x1 minus x0 into x1 minus x2. Okay, this only we have. That is what is this. That is when k equal to 0 to n. Here n equal to 2. If you are choosing these terms, these points only, we have k equal to 0 to 2, and f dash of j, xj is actually x1 here. So x1 minus x. When k equals 0, we have x1 minus x0, and when k equal to 1, we have x1 minus x0, but it is k not equal to j, so we can ignore x1 minus x0 x1, and then k equal to 2, we have x1 minus x2. So these are the this is the remaining product. Okay, so we have f dash of xj equal to this, where xj is any one of where xj is any one of these terms, x0, these points x0, x1, x2, etc., xn. Okay, so this formula is called n plus 1 point formula. This formula is called n plus 1 point formula, and we can use this formula to approximate f dash of xj, right? So in general, if you are using more evaluation points, that is if you are using the points x0, x1, x2, etc., if you are using more evaluation points, this equation produces greater accuracy. It will be more accurate if you are using more data points. There are two most common formulas which are involving three evaluation points and five evaluation points. We will derive only 3-point formulas. We will derive only 3-point formulas, because the 5-point formulas are not included in your syllabus. So we will try to derive the 3-point formulas. That is, we are using the points x0, x1, and x2. Okay, this is actually the n plus 1 point formula, because by using the points x0, x1, etc., xn, that is we are using n plus 1 point data points. Now we are going to derive 3-point formula, that is using x0, x1, x2. So n is equal to 2, so it will be f dash of some xj equal to some summation k from 0 to 2 f of xk lk dash of xj plus etc., and it will be f3, right? When n equal to 2, we have this is f3 of zeta of xj divided by 3 factorial summation the product k from 0 to 2, we xj minus xk. Okay, now we have the L naught of x is equal to, we have the points x naught, x1, x2. So we know L naught of x is equal to x minus x1 into x minus x2 divided by x naught minus x1 into x naught minus x2. So from this, we differentiating this with respect to x, we have this, because the denominator will be is independent of x, because it is x1 minus x naught minus x1 into x naught minus x2. These are some points x0, x1, x2 are some particular points. So this is independent of x, so we can take it as a constant. So derivative of this is nothing but 2x minus x1 minus x2, because we have x into x, that is x square, minus x2 into x minus x1 into x plus x1 x2. This will be the numerator. So differentiating, we get derivative of x square is 2x, derivative of minus x2 into x is minus x2 itself, derivative of minus x1 into x with respect to x, that is minus x1, and derivative of x1 x2 is 0 because x1 and x2 are constants. So this will be the L0 dash of x. In a similar way, we can find L1 dash of x, because we have L1 of x is equal to x minus x naught into x minus x2 divided by, here we are finding L1. Okay, this is divided by x1 minus x naught into x1 minus x2. So differentiating this again with respect to x, we get L1 dash will be this 2x minus x naught minus x2 divided by x1 minus x naught divided by into x1 minus x2. And in a similar way, we can find L2 dash of x is equal to this 2x minus x naught minus x1 divided by x2 minus x naught into x2 minus x1. So replacing these values in the given equation, equation number 1, we have this is equation number 1 is this f dash of xj equal to summation k from 0 to n, etc. This is for n plus 1 point formula. So we are using 3 points x0, x1, x2, that is n is equal to 2 here. So this is equal to summation k from 0 to 2 f of xk lk dash of xj plus fn plus 1. Fn plus 1 is f3 or f triple dash of zeta of xj or zeta j divided by 3 factorial, because n is equal to the product k from 0 to 2 and k not equal to j xj minus x naught. Okay, so this is f dash of xj. That is, when k equals 0, we have f of x0, that is f of x0 into L0 dash of xj, L0 dash of xj, that is, we know L0 of x is this, so L0 dash of this is L0 dash of x, so L0 dash of xj is 2xj minus x1 minus x2 divided by x1 minus x1, x1 minus x2. That is when we replace x by xj, we get this 2xj minus x1 minus x2 divided by this, plus when k equal to 1, we have f of x1 into L1 dash of xj, that is when we replace x by x with xj here, so this is 2xj minus x0 minus x2 divided by this, so this will be L1 dash of xj. Now we have k equal to 2. When k equal to 2, we have f of x2 into L2 dash of xj. That is this. That is 2xj minus x0 minus x1 divided by this. Plus fn plus 1 of, that is f3 of zeta j. F3 of zeta j, where zeta j is nothing but zeta of xj. Divided by 3 factorial. 3 factorial is 6. The product of k from 0 to 2, k not equal to j, xj minus xk, where j varies from 0, 1, 2. Now we can derive the important 3-point formulas from this formula. We have f dash of xj equal to this. Suppose we have the points x0, x1 and x2. Suppose these points are equally spaced. Suppose these points are equally spaced. That is, we have x1 is equal to x0 plus h and x2 equal to x0 plus 2h. That is x1 plus h. Okay, for some h is not equal to 0. That is, the x0, x1 and x2 are equally spaced, right? So in that case, using this equation, we get that is when we replace xj. This is actually when equation number 2, we have f dash of xj. So if we are replacing that xj by x naught, we have x1 is equal to x naught of h, x2 equal to x naught plus 2h. So replacing these values in that equation number 2, we get this f dash of x naught is equal to 1 by h, that is we have here we are replacing xj by x naught, right? So we have f dash of we'll get like this, f dash of x naught is equal to f of x naught into 2x naught minus x1 and we have x1 is x naught plus h. So we have here f of x naught into 2x naught, because xj is x naught, minus x1 equal to x naught plus h. So minus x1 is minus x naught minus h, minus x2 is nothing but we have x2 equal to x naught plus 2h. So minus x2 is minus x naught minus 2h divided by x naught minus x1. We have x1 minus x naught equal to h. So x naught minus h, x1 is equal to minus h. So this is minus h into x naught minus x2 is nothing but minus 2h from this. This is minus 2h. So this term will be f of x naught into 2x naught minus x naught minus x naught. So these x naughts are cancelled. That means the remaining part will be minus h minus 2h. That's minus 3h. That is, this is minus 3h divided by 2h square. That is, we have minus 3 by 2 divided by into 1 by h. So we will get this as 1 by h into minus 3 by 2 into f of x naught, right? That is minus 3 by 2 into 1 by h into f of x naught is here. So this is f of x naught into this, which is f of x naught into this. So the first term will be 1 by h into minus 3 by 2 f of x naught. And the second term, in a similar way, we can find the second term f of x1 into we have this f of x1 into here 2x naught minus x naught, that is x naught minus x2, and x2 can be replaced by x naught plus 2h, and here also we can replace the same. This x1 minus x naught is, this is h, x1 minus x2 is minus h, and here is 2x naught minus x naught, and x2 is nothing but x naught plus 2h. So this is minus x naught minus 2h. So 2x naught minus 2x naught cancelled here. So minus 2h divided by minus h square. So it will be this will be minus 2h divided by negative h square. So 2 by h. So here we have f of x1 into 2 by h. Yeah, 2 into f of x1 divided by h is here, right? And in a similar way we can find this also. So simplifying this, we get this minus 1 by 2 into f of x2 divided by h will be there. So you can just verify that, and the error part will be this f3 of zeta of j divided by 6 into x naught minus xk, because j equal to xj equal to x naught here. So when k equals 0, we have x naught minus x naught, but we know k not equal to j. So x naught minus xk, that is x naught minus x naught will not be there, and when k equal to 1, we have x naught minus x1 into k equal to 2 implies x naught minus x2. So these are the remaining products. So we know x naught minus x1 is minus h, and because this from this, and x naught minus x2 equal to minus 2h here. So minus h into minus 2h, that is 2 into h square. So 2h square divided by 6, that is h square divided by 3. That will be here h square divided by 3 into f3 of zeta naught, that is f dash of x naught. When we replace xj by x naught, and x1 is equal to x naught plus h, x2 equal to x naught minus plus 2h. Now doing the same for xj equal to x1, that is when we replacing xj equal to x1, we get f dash of x1. From this equation we get f dash of x1. In a similar way we can find that also. So you just try that, you will get this f dash of x1 is equal to 1 by h into minus 1 by 2 f of x naught plus 1 by 2 into f of x2 minus h square divided by 6 into f3 of zeta 1. And if you are replacing xj by x2, we will get f dash of x2 in the from the same equation. If you are replacing xj by x2, we get f dash of x2 equal to this, that is 1 by h into 1 by 2 f of x naught minus 2 into f of x1 plus 3 by 2 into f of x2 plus h square by 3 f3 of zeta of 2. So we obtained f dash of x naught, f dash of x1, and f dash of x2. Now by using these three formulas, since we have x1 is equal to x naught plus h and x2 equal to x0 plus 2h. So replacing these values here, that is we have these three formulas can be written as we are going to replace this x1 by x0 plus h and this x2 by x0 plus 2h. So replacing that values, we get these equations are given by this. The first equation will be f dash of x0 equal to 1 by h into minus 3 by 2 into f of x0 plus 2 into f of x0 plus h. It will be f of x0 plus h minus 1 by 2 into f of x0 plus 2h plus etc. That is, we will get this equation formula, and the second one, f dash of x1 will be like this: f dash of x0 plus h is equal to 1 by h into minus 1 by 2 into f of x0 plus 1 by 2 into f of x0 plus 2h. That is this. F 1 by 2 into f of x0 plus 2h is this, minus h square by 6 into f3 of zeta 1. That's from this. And from the third one, we can replacing this values here, we get f dash of x0 plus 2h is equal to this formula. So by using these, we can transform these three equations like this. Now, for convenience, in the second equation or second formula, if you are replacing x0 plus h as x0, that is we are going to find f dash of x0. That is, we are replacing in the second formula, we are replacing x0 plus h as x0, substituting x0 plus h x0, and in the third one we are replacing x0 plus 2h as x0. Okay, so in the second one, if you are replacing x0 plus h as x1, that is replacing x0 plus h as x0. So we have this if x0 plus h is equal to x0 implies x0 is nothing but x0 minus h, right? This will be if you are replacing this x0 plus h as x0, we have x0 is equal to x0 minus h, or x0 we changes to x0 minus h, and x0 plus 2h changes to x0 plus h, right? If you are changing x0, that is x0 plus h is changing to x0 implies x0 changes to x0 minus h, and x0 plus 2h changes to x0 plus h. So we have the second formula will be transformed into this formula. Okay, that is f dash of x0 is equal to, we are replacing or transforming x0 plus h as x0. Okay, so we have this, it is minus 1 by 2 minus 1 by 2 into f of x naught minus h plus 1 by 2 into f of x naught plus h. So taking 2 outside, here we get 1 by 2h into minus f of x naught minus h plus f of x naught plus h minus h square divided by 6 into f3 of zeta 1. And in third one, we are changing x naught plus 2h, right? X naught plus 2h as, that is x naught plus 2h, as we are changing this as x naught. So f dash of x naught. In that case, we get x naught will be changed, or x naught plus h will be changes to x naught minus h, and x naught will be changes to x naught minus 2h, right? If you are changing x naught plus 2h as x naught, the x naught plus h will be changed to x naught minus h, and x naught will be changed to x naught plus minus 2h. So this equation will be transformed into this: f dash of x naught is equal to 1 by h into 1 by 2 into f of x naught. That is f of x naught will be, that is x naught will be changes to x naught minus 2h, so x naught minus 2h minus 2 into f of x naught plus h. X naught plus h changes to x naught minus h, so minus 2 into f of x naught minus h, and here it is 4 because we are taken 2 out, 1 by 2 outside. So here f of x naught plus 2h is nothing but f of x naught. Okay, so this is h square, and here the h square by 3 f3 of zeta 2. Okay, so we obtained three formulas we can use to find f dash of x naught. Okay, but in the previous case, it is this can be used to find f dash of x naught, and it is f dash of x naught plus h. This is f dash of x naught plus 2h. But in this case, each of these three formulas is to find f dash of x naught itself, right? Now, if you are checking the first and third formulas of these three formulas, that is, third formula is actually obtained by replacing h with minus h from first equation. That is, if from this equation, if we replace h by minus h, we will get the third one. That is, here we have minus 1 by 2h. When we replace h by minus h, we have minus 1 by 2h, and here is minus 3 f of x naught will be here. This is f of x naught minus h, f of x naught minus 2h. But here, if you are taking negative outside, we get 1 by 2h into f of x naught minus 2h, f of x naught 4 into f of x naught minus h, plus 3 into f of x naught. And it is the, and we are replacing this h by minus h, we will get h square is into h square by 3 f3 of zeta 2. So these two equations or formulas are same actually. That is, the third one is obtained by replacing h by minus h from equation number 1 or formula number 1, right? So actually there are only two formulas, which are 3-point endpoint formula and 3-point midpoint formula. That is, the first one is actually, we know these first one and third one are same, so it is called 3-point endpoint formula. That is, 3-point endpoint formula is f dash of x naught is equal to 1 by 2h into minus 3 f of x naught, etc. So that is the first one. So this is the 3-point endpoint formula. We know these are actually equal, right? And the second one is called 3-point midpoint formula. Okay, 3-point midpoint formula, because we are finding this. This is actually, second one is actually the derivative at the point x naught plus h. X naught plus h is the midpoint of our points. We have the points x naught, x1, x2. So x1 is equal to x naught plus h. So f dash of x naught plus h is actually, this is because this formula is called 3-point midpoint formula. And this formula uses the value of f at the point x naught minus h and x naught plus h to find the value of the derivative at the point x naught, or to approximate the derivative of f at the point x naught. We are using the value of f at the point x naught minus h and x naught plus h in the 3-point midpoint formula, right? That is this. And the first one is the 3-point endpoint formula. Now, although the errors in both equations 3 and 4 are of h square, we know the error is in 3 is this. In both these equations, we have the errors are order of h square, but the error in equation number 4, that is in midpoint for 3-point midpoint formula, the error is approximately half the error in equation number 3. That is, the error in 3-point midpoint formula is approximately half the error in 3-point endpoint formula. Okay, it is because we are using in this equation, that is in 3-point midpoint formula, we are using the values of f at the point x naught plus h and x naught minus h. That is, we are using the data on both sides of x naught. But in equation number 3, that is in 3-point endpoint formula, we are using the data from one side. That is, for approximating the value of the derivative at the point x naught, we are using the value of f at the point x naught plus h and x naught plus 2h. That is, we are using the values at one side of this x naught. Okay, so the error in this formula will be approximately half of the error in this formula. Also note that f needs to be evaluated at only 2 points in equation number 4. That is, in the 3-point midpoint formula, we need to evaluate the value of f at 2 points. But in the case of 3-point formula, that is 3-point endpoint formula, we need to evaluate the value of f at 3 points. That is at the point x naught plus h, and x naught plus 2h. Right. The approximation in 3, that is the 3-point endpoint formula, it is useful near the ends of an interval, because the information about f outside the interval may not be available, because here because we are using for this formula, we are using the values, that is to find the to approximate the value of f dash at the point x naught. We are using the points x naught plus h, x naught plus 2h. We are not using the values x naught minus h, minus 2h, etc. That is, we are not using the values outside the interval. So to approximate the derivative near the endpoints, we can use this formula. Now we can discuss a problem in the next lecture.